So hello to friends in the room, friends who I know are joining us virtually. I'm really excited that you are here, and thank you, Justin, for having me. It's great to be here. This is part of a big bunch of research that I started some way or another 13 years ago and some way or another in 1996 even. And I want to start by making the claim that architecture, AI, and design are all connected. These connections go back some 60 or 70 years to 1956 or even 1948. And newness seems to be central to how we talk about artificial intelligence today. We say things like AI is the new black, AI is the new UI, artificial intelligence is the next digital frontier, according to our friends at McKinsey. Andrew Ng stated that AI is the new electricity, but also AI is the new MOOC, because it will be an online course that he's running. You need data for AI, so data is the new oil. The future of computers is the mind of a disembodied toddler head. And apparently I am also the new AI, and I will spare you this, what this says, but it's really, really sexist and really awful. And if you want to get an idea of how much the word new gets used when we talk about AI, you could look at something like this MIT Technology Review article. I just highlighted the word new where I could find it, and there were 6 mentions in the first 2 paragraphs. Of course, I think one of them was New York, so I don't think that that actually counts. And this gentleman was a part of a conversation about tech moguls declaring an era of artificial intelligence. But AI isn't the new, because AI isn't new. Here's how new it's not. 1955, John McCarthy, the founder of the Stanford AI Lab, and before that the MIT AI Lab, coined the term artificial intelligence to mean making machines do things that would require intelligence if done by man. In 1956, he brought together a group of researchers at Dartmouth College in New Hampshire, and they spent the summer hashing out what they thought the platform of research on AI should be. And it included things like neural nets, and it included, what does he say? He says, an attempt will be made to find how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. We think that a significant advance can be made in one or more of these problems if a carefully selected group of scientists can work together on it for a summer. 1956. Herb Simon, Alan Newell, and J.C. Shaw, Simon and Newell, very important to Carnegie Mellon's history, wrote in 1958 that they'd pretty much figured out this problem of modeling the human brain in computing. They said intuition, insight, and learning are no longer exclusive possessions of humans. Any large-scale, high-speed computer can be made to exhibit them also. They believed that by the 1960s they'd have it figured out. And of course, Marvin Minsky, who in 1961 said, I believe that we are on the threshold of an era that will be strongly influenced and quite possibly dominated by intelligent problem-solving machines. Proto-machine learning you might find in the world of perceptrons in 1958. The New York Times published an article talking about this new Navy device that learns by doing, and said that the Navy revealed the embryo of an electronic computer today that it expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. The Navy said the perceptron would be the first non-living mechanism capable of receiving, recognizing, and identifying its surroundings without any human training or control. So all of these ideas are really old. They're older than me by far, and they're older than a lot of what we work on. But in addition to this, I want to point out that AI and architecture are old friends and kind of co-created each other at a certain point in time in ways that has very direct impacts on the kind of engineering and design work that we do today and the problems that we focus on. I'm going to introduce 3 of the characters in my book, Architectural Intelligence. The 3 people I'm going to introduce in this talk are Christopher Alexander, Cedric Price, and Nicholas Negroponte. Who here has heard of Christopher Alexander? Couple. Anyone Cedric Price? Right on. And Nicholas Negroponte. couple more. All right. So they're all architects who worked very closely with technology in different kinds of ways, some so much so that you don't probably think of Nicholas Negroponte, the founder of the MIT Media Lab, as an architect. And I'm going to talk about the ways that they worked with cybernetics and artificial intelligence to build new kinds of worlds and new kinds of approaches in ways that affect what we do today. I'll start with Christopher Alexander. Christopher Alexander, if you do know of his work, and even if you don't, by me putting up this book right here, I've probably begun to bring him into something you've heard of before. He's written many, many books. He's a mathematician, born in Vienna, raised in England, came to the United States in the 1960s. He's quite old, but still alive, living in England again, was a professor at Berkeley. And I'll mention 3 books today. Notes on the Synthesis of Form, A Pattern Language, and The Timeless Way of Building. Notes on the Synthesis of Form was his thesis, and if you've ever heard the idea of design being good fit or fitness, trying to shim a table until it kind of works, or putting a stable system in place, that's where that idea comes from. Those of you who've used patterns, whether in UX or in software, are right in the lineage of Christopher Alexander. His idea of pattern languages have influenced this, and then his philosophy of design, which he outlined in The Timeless Way of Building. If you've ever used a wiki or you use agile processes, you have used something that he's done. My own research with Alexander started when I was reading Notes on the Synthesis of Form, and this question of AI came up when I realized in a footnote he was referring to Shannon and Claude Shannon, John McCarthy, and Marvin Minsky. And I wondered, why is this architect? What does he have to say about artificial intelligence in 1964? 13 years later, I have a book about that. He was interested in finding ways to break down design problems so they could be easily understood and designed. Anybody who has created tree diagrams in order to explain the function of a piece of software or website is working in this lineage. In fact, this is the outputs of one of his programs this is something that's in the Berkeley archives that shows how you'd break down the elements of a design problem for how you design highways. He also applied these ideas to the BART system in 1964. This is 390 requirements that he and his team outlined, and this is before BART was built. I'm not sure how many of these are in place today. I think we probably need new requirements. My ears are still ringing from the BART ride I took this morning. Pattern language and timeless way of building I already mentioned briefly, but I want to tell you a little bit more about them. The pattern language, as he puts it, and it's not the only, it's a pattern language. It's 253 patterns from large to small scale, and then the timeless way of buildings is a philosophy of patterns. And these patterns are anything from how to make a nation state down to how to organize your bedroom. And as he and his collaborators write, each pattern describes a problem which occurs over and over again in our environment, and then describes the core of the solution to that problem in such a way that you can use this solution 1,000,000 times over without ever doing it the same way twice. So in the book, here's an example of a pattern. I live in Pittsburgh and I live in a row house, and so it's very dense where I live, and these are patterns about the design of a row house. You see a number, a statement, a picture, a statement about the design problem, illustrations to carry out, to explain some of what that design problem is doing, and then a connection to other patterns in the system. And it works sort of like an operating system. The patterns are a network. So you see here are a number of them in their order explaining what each of them do. This is going from a mosaic of subcultures all the way down to a household mix, and it goes further and further into more detail. Alexander is someone that a lot of technologists have read. If you know Alan Cooper, the interaction designer, he used to ferret out Christopher Alexander's books in his high school library and read them there. He wanted to be an architect, so did Kent Beck, and then realized he didn't want to build buildings, he wanted to build software, and there was a lot more that you could do within that world. And Ward Cunningham and Kent Beck were curious about how they could apply this idea of patterns to the idea of object-oriented programming languages. So they applied it to interface patterns in Smalltalk in the late 80s, in about 1987. And a community of programmers got together and over the years built up what was called the design patterns movement. And this group of 4 men who called themselves the Gang of 4 are the ones who created this kind of network of design patterns in software. And it's an idea that you see millions and millions of times. I think there's something like 1,200 books on Amazon that refer to design patterns in software and in interfaces and games, whatever. Okay, now how many people have heard of design patterns? There you go. Also, if you've ever used agile processes or followed extreme programming, Kent Beck and Ward Cunningham and a number of other people applied these ideas about the philosophy of design from Christopher Alexander and the timeless way of building to upend and change the politics of the design process and to give more flexibility to users and to people. And when I interviewed Kent Beck, he told me that it was a rearrangement of the political power in the design and building process. Everyone here has used a wiki. And the wiki format was developed by Ward Cunningham. He was developing it in HyperCard in the early 90s, and then it was suggested that he could maybe build this on this new thing called the World Wide Web. And what he wanted to do was have a conversation that never had an end. If he wanted to map all of the knowledge he had that he and his team had, he didn't want to say it ends here. He wanted it to be able to go and go and go. He never patented the wiki format, and it was picked up in the early 2000s to run Wikipedia, and now we've all used wikis one way or another. But this is, again, a direct inspiration or a direct influenced by Christopher Alexander project. Okay, so that's Christopher Alexander. The other thing to say about him is architects tend to hate him and technologists tend to love him. I'm not sure why. Conundrum, but kind of interesting. So I'd like to introduce you to a different kind of architect. This is Cedric Price. I've called him the secret patron saint of interaction designers. He changed the way any number of people in the UK understood architecture and buildings and what they could do. His life partner was Eleanor Braun. He died in 2003. Eleanor Braun was in the Beatles movies and was responsible, actually she was the inspiration for the song Eleanor Rigby. So just a very curious and very funny person who liked to ask things like, technology is the answer, but what was the question? And Cedric Price was best known for things that were never built. So for instance, the Fun Palace was designed in the 1960s, and it was supposed to be a big cybernetic theater, movable kind of place where all sorts of things could happen. And the space was going to learn from its users over time and adapt to their interests and needs, and you could change it over time and use it kind of as a big leisure center to learn and experience whatever it is you might want to learn. And he worked with a 27-member cybernetic community, which is what you see here on the right. And in this particular image, it's kind of hard to read, but it talks about input of unmodified people and then output of modified people. So they thought through this like a system diagram. He did this project with Joan Littlewood, who was a radical theater director and a protege of the German playwright Bertolt Brecht. He also was really inspired by Gordon Pask, and Gordon Pask is a cyberneticist who also had a big influence on a lot of architects. And a piece that he wrote in 1969 talked about changing this design process in some interesting ways. And he suggested that we turn the design paradigm in on itself and let us apply it to the interaction between the designer and the system she designs, rather than the intersection between the system and the people who inhabit it. So rather than the system you designing doing your bidding, maybe it does something different. Maybe it augments and creates something different than what the two people put together. This is a drawing he gave of second-order cybernetics. He wrote things like, "Assume for the moment I am the successful businessman with the bowler hat, and I insist that I am the sole reality where everything else appears only in my imagination. I cannot deny that in my imagination there will appear other people, scientists, other successful businessmen, etc., as for instance in this very conference. Since I find these apparitions in many ways similar to myself, I have to grant them the privilege that they themselves may insist that they are the sole reality and everything else is a condition of their imagination. On the other hand, they cannot deny that their fantasies will be populated by people, and one of them may be I with bowler hat and everything. So this is second-order cybernetics, where the fact that you're engaging with the system changes the system. And if you start looking at the design process as something that needs to take that into consideration, design begins to look a little bit different. Cedric Price was, again, very inspired by his interactions and collaborations with Gordon Pask. And one of the one of the projects that he designed was something called Generator. This was never built, but it was a project that was in existence from 76 to 79. And it was a set of 12-foot cubes, 150 cubes, walkways, boardwalks that could be moved around and recombined for whatever purposes someone might like. This was an arts retreat center for a wealthy patron in Florida. He always really liked moving cranes, so there's always a moving crane here, and Generator would come together like this. There was grid on the ground, you'd put cubes over it, roofs on top, connect the parts, and then you could put up the side baffles and the stairways and do what you'd like with this space. You could also model it with these little qubit parts that you would see. He thought that maybe fun things might happen, like you could take a bleeper walk. I will remind you, this is 1977 or so when this idea came up. And something strange about a mouse rolling around a cube. But it's strange and weird and funny all the time. And again, we look at Gordon Pask. Gordon Pask did a project first in 1953 and then in 1968 called, which became the Colloquy of Mobiles. And what happens with these mobiles are you interact with it and it interacts back with you until it gets bored. And Paul Pingaro, who is a cyberneticist and a professor at the College for Creative Studies in Detroit, has just rebuilt the Colloquy of Mobiles for the 50th anniversary of the original project. He's Gordon Pask's archivist, and it's up right now as we speak in Detroit. So this is, what does this have to do with Generator? Well, Cedric Price realized it was unlikely that people were going to want to move around Generator enough and learn from it and do the kind of funny things that it would expect. So he began to work with John Fraser and Julia Fraser, who were computer scientists as well as architects, and wanted to put together a set of programs that people could use that would be used by Generator. So there would be microcontrollers on all of its parts, an inventory program, a design program. That's what you see here. You can pick up and move these cubes and they plot and print out, and a boredom program. And the boredom program said the following: in the event of the site not being reorganized or changed for some time, the computer starts generating unsolicited plans and improvements. And this is something that John Fraser wrote in his letter to Cedric Price introducing these programs. If you kick a system, the very least you would expect it to do is kick you back. And then he said, you seem to imply, this is a handwritten footnote that you can kind of see down here in the letter, you seem to imply that we were only useful if we produced results that you did not expect. I think this leads to some definition of computer aids in general. At least one thing that you would expect from any half-decent program is that it should produce at least one plan, which you did not expect. So this is where something like Gordon Pask's Colloquy of Mobiles makes its way into Cedric Price's architecture. And these are ideas that we pick up today in some really lovely ways. On the next slide, I'm going to introduce a project by the roboticist Madeline Gannon. She just finished her PhD at Carnegie Mellon in architecture, and she did an exhibition at the London Design Museum with a robot, a robotic arm that would play with somebody in its midst until it got bored and went away.
Everything comes together and you're in the space with the robot and you just have a very raw experience with this animal-like machine responding to your every move. All the technical aspects sort of melt away into the background. It's incredibly important to have opportunities and spaces to come in and experiment and misuse these existing technologies.
she didn't know about Gordon Pask or Cedric Price when she did this project, but I find it compelling that many years later, this is exactly what she's trying to do in trying to get us to rethink our relationship with our machines. She calls herself the robot whisperer. Third person I'd like to talk about is Nicholas Negroponte. You'll notice here he always seems to have his fingers in the picture. He always seems to be gesturing at something. You would probably know him as the founder of the MIT Media Lab, but before the Media Lab, he ran something called the Architecture Machine Group at MIT. And that's what I want to talk about here. The MIT Architecture Machine Group was in the School of Architecture, but worked very closely with the AI Lab and developed interfaces, programs, and environments for artificial intelligence. The gesture thing, he's the author of a number of books. The book that you'd probably be most likely to know would be called Being Digital, and Being Digital came out in 1995. But in 1970, he wrote a book called The Architecture Machine, and he dedicated it to the first machine that can appreciate the gesture. Nicholas Negroponte is a clever man, but this book, I think, is actually fascinating and really important. It was a theory of design for artificial intelligence that I think still holds weight today. I want to point out a little bit about the funding structures of the Architecture Machine Group and of artificial intelligence in general. The Architecture Machine Group was funded by the Information Processing Technology Office of DARPA and the Office of Naval Research. The Office of Naval Research was so important for defining the funding for artificial intelligence from pretty much its inception onward through the 80s. So vital that I think that Marvin Minsky has referred to Marvin Denikoff, who was the program officer, as the grand old man of artificial intelligence. So the thing to point out is something that Paul Edwards, the historian, has referred to as the closed world, that artificial intelligence was primarily developed within Department of Defense funded entities because it meant a small group of people could continue to work on these projects through the same social network, friendship networks, and professional networks that had been developed since the end of World War II. Where NSF funding, National Science Foundation funding, kind of automatically and by its very spirit tried to throw things open to the world and open things up and bring more people in. So it was desired by DARPA IPTO, and ONR to keep funding and development in these small networks of people and to get things done better. And it meant that the Architecture Machine Group started to structure their work like the AI Lab did at MIT and work very closely on interfaces and small machines and environments for artificial intelligence. One of these first projects was funded by IBM. It was called Urban 2, or Urban 2 and then later Urban 5, and it was a conversational user interface for urban design. This is 1970, actually started a little bit before that. And what happens here is a user chooses a set of blocks. You see these squares down at the bottom, and then there's a conversation going on at the side using this light pen to select questions and answers. And it asks you questions, and you use the conversational dialogue and the buttons here to determine what the attributes are of these areas that you are designing. So it's for urban design. And the Architecture Machine Group book, or the Architecture Machine book outlines and critiques their study here. You might notice this last one that says, "Ted, many conflicts are occurring." And they said, you know, it was charming, but it printed garbage, but at least it was friendly garbage. Those are the words that they used. And I think it points out, if anyone here has tried to design a conversational user interface, you know how easy it's going to seem on the surface and how hard it is in reality. And even just in what we could look back to someone like Joseph Weizenbaum in 1966, who created ELIZA, the therapy program. It's a question and answer conversational user interface. And very difficult and problematic in ways that caused Joseph Weizenbaum to rethink his own total engagement with computation and artificial intelligence. So everybody knows that this is difficult to do, and yet we continually try to do it anyway. Nicholas Negroponte and Marvin Minsky were friends throughout Nicholas's entire professional life until Marvin's death a couple of years ago. And here you see a robotic arm stacking blocks. This is a lot of AI problems were developed in what were called microworlds, right? So you focus in on some small part of a project, some small issue, right? You're looking at edge finding, you're looking at computer vision. In fact, you're still today thinking about computer vision in some very specific small ways. I know Justin was just taking a computer vision class at Stanford. And you try to throw away the rest of the noise and just focus in on that problem. And that's appropriate for some period of time, but after a while, microworlds didn't actually scale up, and this gets to be a problem. But as I mentioned, the Architecture Machine Group worked in microworlds as well, in AI interfaces. And this is a project that they did in 1970 for the software show. It was a museum show at the Jewish Museum. And information technology, its new meaning for art. And so here you see all of these cubes. Isn't it funny? Like Generator has cubes, and Urban 5 has cubes, more cubes. And you've got this set of mirrored blocks, 400 mirrored blocks, a 5-foot by 8-foot pen, and a gerbil horde, a gerbil colony living there. And it's going to be difficult to read this, but it says gerbils match wits with computer-built environment. And what Seek did was stack blocks, and what gerbils did was move them around and knock them over. And this is the gatefold of the software catalog, the life in a computerized environment. And there's this great quote from Ted Nelson, who says, "Our bodies are hardware, our behavior software." And it's Paul Pangaro, who made the contemporary colloquy of mobiles, and a member of the Architecture Machine Group, who told me it was a little bit too true because Seek tended to kill the gerbils. In later days, the Architecture Machine Group turned to command and control interfaces that were explicitly, that had explicit military connections and applications. And this is because the only way past 1974 that you could get work in artificial intelligence funded was to align it with command and control questions and direct tactical military applications. This is due to some legislative things that had happened in the 70s in the wake of the Vietnam War. And so this is the Aspen movie map. It is kind of what it looks like, Google Street View that you experience sitting in a room in a chair. You zoom down the streets of Aspen, Colorado in an Eames lounge chair with joypads, and a video disc produces the images for you. They had a prototype video disc player in the 1970s, and the way you get the images is everybody goes to Aspen on vacation and you load up the Jeep, and that's what you have right here. So you zoom down the streets, and there are other photos that show what's in front of the two smaller screens are usually maps and are on touch screens. I want to point out that part of the reason this project was funded was it was in the wake of the jet rescue, the hostage rescue in Entebbe, Uganda. A number of Israelis, an Israeli jet had been hijacked, and the rescue of the hijacking was performed by building a model desert or a model airport in the Negev desert, and practicing the rescue under cover of darkness. In fact, I think this is the subject now of a movie that's about to come out or is coming out later this year. And so the question here became what would happen if you were able to actually simulate and do remote moving and move down these streets. So that would be the stipulation for this project. In later years, they were really explicit about this in some of the reports they wrote. Minsky and his colleague Richard Bolt wrote that we are proposing to develop human-computer interfaces on the one hand as sophisticated in conception as a cockpit, and on the other hand as operationally simple as a TV. From either perspective, the objective is the same: supreme usability. Later on, they started delving into virtual reality in certain ways and questions of augmented reality. So this provocation in mapping by yourself is a postcard held up in front of the Queen's Palace in Stockholm and imagining what it would be like to have a screen that overlaid information upon the world. On the other side is a Westinghouse Westinghouse window, basically a very early iPad-like thing that was still connected to various technologies. And you can kind of see in the background that there's a Selectric typewriter and a dictaphone. But this was a mapping window and intended to substitute for maps in the battlefield. It had 2-dimensional and 2.5D capabilities depending on how you would flip it. And this is apparently the first example of a layered digital map. I like the fact that Nicholas Negroponte has always understood what he has been working on and the conundrums and contradictions about it. And in his 1975 book, Soft Architecture Machines, he said, "I strongly believe that it is very important to play with these ideas scientifically and explore applications of machine learning that totter between being unimaginably oppressive and unbelievably exciting." And I find myself, as I look at these historical examples and where we are today, I find myself wondering if we need new cliches. Because when I do Google image search and pop in AI, this is what I get. There's always this, the wavy, or the behold the hand. And it's always that color blue. It's like the blue of the projector when no one's in the room. JSON lady. I think no, this is jQuery, right? Yeah, cyborg lady. If these are our views of AI in the future, I think we're in trouble. But I appreciate some of the subversive ways that we can look at this and some of the fun ways that we can as well. Is anyone here a fan of Jenelle Shane in AI Weirdness? I nerded out so hard at I/O this year when I got to meet her. She does very funny things with AI that I'll talk about, but I really appreciate that she understands what she's doing. And she said, if life plays by the rule, image recognition works well, but as soon as people or sheep do something unexpected, the algorithms show their weaknesses. So are these orange flowers in a field or sheep? Because she colored them orange, it's not sure anymore. Jenelle has also done things like, this is 7,000 paint colors fed to a neural net, and it begins to create new colors, all of which are terrible, and color names. Exactly. I've been reduced to tears multiple times. Caring Tan, Burble Simp, Turdley, Ranching Blue, Tondar. She fed the names to the names of guinea pigs for the Portland Guinea Pig Rescue and came up with some names for guinea pigs. Here we have Hanger Dan and Princess Pow. And my husband has said, I think any kid could come up with Princess Pow, but it takes a neural net to come up with Hanger Dan. Only machine learning can produce. And again, when I think about these kinds of things, I also find myself thinking about this, which is actually, it apparently was not Marcel Duchamp who delivered this to the art show in 1917, this urinal, as his object, but rather a woman whose name I can't remember. They've just surfaced that it wasn't him. But this was part of Dadaism, where the world was going to hell. It was World War I, and things were really, really dark. And so what does art mean when things are really dark? It means that you've got to turn to absurdity. You've got to turn it upside down. And so art starts to look different. Or you look at someone like Eugene Ionesco, who wrote the play Rhinoceros in 1959. It's an absurdist play, and it's where a group of people in a French town, bit by bit, turn into rhinoceroses. And of course, he's talking about totalitarianism. Ionesco wrote a play called The Bald Soprano because he had started to try to learn English. He's French-Romanian. And in order to learn English, he would type phrase after phrase from this kind of English book. John and Sally go to the store, and over, and he began to question the nature of these meanings. It's almost like he became his own algorithm in order to learn this, and he produced a very funny play called The Bald Soprano about it. Or you could even look at something like Boon Yell, Louis Boon Yell, who did Un Chien Andalou in the 1920s, 19-teens. But in 1970-71, something like that, he did The Discreet Charm of the Bourgeoisie, which is about a group of people trying to have dinner and they just keep getting thwarted. And it's a somewhat contemporary surrealist film. But all of these things are ways to, when the world is on its head, you upend it in art. And I want to suggest that maybe we should be doing the same things more frequently with our algorithms. Can anyone name what this is? Thank you. Okay, I was saying that, but yeah, it's exactly what it is. And the Uncanny Valley is an idea from 1970 from Masahiro Mori. And what I'm struck, this is the idea that when robots are too similar to us, they freak us out. And he describes the eeriness that produces. But he says something else in his piece, in the article he wrote in 1970, which is that it's about how we understand what makes us human. We should begin to build an accurate map of the Uncanny Valley so that through robotics research, we can understand what makes us human. Until recently, Manuela Veloso was the head of the machine learning program at Carnegie Mellon. And I was at a conference that she was speaking at, and she was talking about machine learning is successful when it does what you expect it to do. And for Cedric Price, we saw the goodness of when something doesn't do what you expect it to do. But there's some dark things too. The stories that came out earlier this spring about Palantir's predictive policing in New Orleans, and the fact that had not been known, not even to most people in the city of New Orleans or city officials. I like the work a lot of Mimi Onuaha. Some of you may know her work. She does a project called Missing Datasets, and you can't parse what you don't collect. And so if you don't have the data, you can't begin to parse it. She does this both as a tech piece and a critical piece and an art piece. So here you see a lot of folders full of missing data sets, and of course, if you go look through them, they're all empty. She keeps a GitHub repository where she has these missing data sets. And this one, civilians killed in encounters with police or law enforcement agencies, is no longer a missing data set. It's been collected. And so she'd like to see more of those. And case in point, sometimes there's an activist angle to her work, but there's also work that happens as a result. A group of Asian actors on Broadway contacted her about the roles that are available for Asians on Broadway. And that blue line is the Asian roles in the play The King and I. And the other bright light blue that you see are Asian roles elsewhere in the 2014-2015 season. Similarly, you can see the problems for Black actors or Hispanic actors, just not a lot available at that point. But by collecting this data, it became possible to change the equation, and now there are more Asian actors on Broadway. This is not a matter of an algorithm, but it's just quite simply a matter of the collection of data and collecting the data and naming it, making changes. Oprah. But I'm struck by the things that machines don't do, that we don't have good machines for picking raspberries, and we kind of do for picking strawberries, but it's very, very difficult to get this right, to manipulate, to do this properly. And I'm struck by the fact that if you, I think it was in Sweden, there was a mining operation that had a truck that had some very nice machine learning algorithms operating it more efficiently, and it was so efficient that it dug itself into a rut and couldn't get back out. So they had to introduce noise into the system to allow for the vehicle to not too expertly dig itself into the ground. So in closing, I'll say that AI is new, but it's also old, and that it is a matter of architecture. It's a matter of infrastructure, and it's a matter of how we design. This is something I see in my neighborhood in Pittsburgh. I go running by Carnegie Robotics. I'm not totally sure how I feel about it. Yeah, I'm still not sure how I feel about it, but I think it's pretty compelling. But this is the thing that I do come back to over and over again, which is our man Cedric Price, who says technology is the answer, but what was the question? Thank you.
Hi, my name is Xavier Malina. I'm an analyst here at Google. And I've been getting really interested in some of the things happening on the edge of this space, like generative design and some of the stuff that Autodesk is working on.
Yeah.
And I'm curious as to how, where you see the space evolving sort of like fastest. Because, like 3D printing, there's usually industries that pick it up first. Like, where do you see like the first sort of mass market case of architectural, AI or intelligence really happening?
That's a really good question, and I'm not sure if I have a well thought out answer, but I'd point out that the history of 3D printing is already quite old, and so what we see the uptake in now at a consumer level or at a professional level. And the other thing is I don't think that 3D printers, I think they became something that it was said they were going to transform everything in the world, and so then everybody started getting maker spaces, and I'm not sure that has actually, printing objects has made the world change. But the question of generative design, I think that architecturally the primary focus has been on form and representation. You use any number of authoring programs and design programs to produce work that you wouldn't be able to otherwise. I get very curious again about these old ideas that I still think are vital about how they change the design process and the ingredients that go in that make us think of something that isn't necessarily just ending up in form, but ending up in how we construe design. But that's, yeah. Thanks. It's a good question. Now I'm going to try and figure out the answer.
So Rohit says, any thoughts on Bill Mitchell's role, City of Bits, and or urban design on software, other than SimCity?
Oh, Bill Mitchell. Bye. Bill Mitchell was at points the dean of the School of Architecture at MIT. He ran the Smart Cities Lab, absolutely vital individual. He's actually an alum of my master's program, and he died about 5 years ago. And I didn't write about him very much in my book. I was focusing on a slightly earlier era. But he's a totally vital figure, and there's a woman named Anne-Marie Brennan right now, she's a graduate of my PhD program, in Melbourne, Australia, who's been working on some of his work and using his archive there. So I think we're going to see some stuff forthcoming about Bill Mitchell. But you also see his work you see how he's inspired people, including like Anthony Townsend, who wrote the book Smart Cities, and has been thinking a lot for the last 20 years on urban planning, smart cities, and development. I guess from a smart city perspective, I keep going back to two big concerns that smart cities tend to be, and again, I get to say this because I'm an academic, I guess, but it seems to be viewed as the locus of really great big enterprise deployments. Like if we used to get excited about enterprises, the scale of a building or a campus, this is even yet still more tech, and a lot of it hasn't been very graciously designed. I also think of that idea of microworlds, that the question of scale is really vital, but when we say scale, it means a lot of different things. Like, is it 1 to a billion? Is it tiny to great big? Is it has many more users? Is it has many more stakeholders? And I think designers and architects are really well positioned to talk about issues of scale. But it's the hardest thing, I think, for us to figure out what we mean when we mean deploying on that kind of scale. Thank you, Rohit.
Hi, my name is Christine.
Hi, Christine.
I just wanted to ask, what are you most excited about that's getting researched now, or an idea that's you might have just heard about? What in this field are you most excited about?
Thanks for that question. That's a really nice thing to be asked. Well, I recently received this named professorship, and it's it's the K&L Gates Associate Professorship in Ethics and Computational Technologies. I'm not an ethicist. I'm a designer and I'm a historian. And I'm really curious about what we talk about when we talk about ethics, because I don't think that it means ethics per se. You can't just sprinkle some ethics on top and make the food salty, and that doesn't work. And it makes me remember that time in like the 90s and 2000s when people discovered usability and said, we need some usability on this website. And like, no, you don't want usability, you want it to work. You want it to be good. And I'm gonna leave here and go to Stanford to meet up with Fred Turner, who, if you haven't read his recent pieces in Logic and in 032C, you should. The 032C piece came out this week. The piece in Logic is a few months old, so he's the head of the communications department. He's a historian of, among other things, Silicon Valley. And we're grappling with a question about education, and he's speaking about engineering, writing about engineering education, but I mean, I think anyone who's going to work with stuff, how do we educate people? Engineers are increasingly, Fred will argue, STEM-oriented, and then anything else is relegated to other departments. But how do you make an ethical approach not be a blow-off class? How do you make it be a part of the data sets or the problem sets you're working on? Part of my interest in casting the role of design to work in different kind of areas is because of that. I'd like to, you can work with designers on framing a problem, determining what data should be collected, how it should be used, how it should be visualized or explained. So I have questions about that. I have questions about the possibilities and impossibilities of explainable AI. And honestly, if you just sit me down with like a new history or a bunch of documents about the history of AI, you won't see me for a while, because I'll be very happy if I can go back into that stuff. But I think we have some very human questions that also meet the jobs of the people in this room and the people on my campus and probably the places that we all studied, that need broader approaches than just the most efficacious and effective and efficient approach. Thanks.
So one more question from the Dory, also from Rohit. Why aren't there more real architects celebrated in the field of software architecture other than Christopher Alexander?
Bless you for asking this. It's so great. Thank you. Yeah, I asked Alan Cooper a couple of years ago, can you name another architect? And I did this to Kent Beck too, and just silence for... And I think that Kent Beck said Le Corbusier, and I think Alan Cooper said, is it John Portman, the guy who did the Embarcadero Center and, you know, the Bonaventure in LA. It would be better if we had other architects, but I think the other thing is that Christopher Alexander, as a mathematician, and as something, I mean, it's something that everyone in the room deals with. You work on some very tiny part of an absolutely huge problem. How do you go back and forth? How do you keep that in your head? And Christopher Alexander can explain that to people in a way that is really resonates with them, the working on these two scales, and then explaining why it actually matters on like a cosmological sense. His late stuff is very woo-woo. And that really resonates, and it really doesn't resonate with most architects who build buildings. So I would like to see I'd like to see Cedric Price get taken up by everyone else because he's fun. Alexander's not much fun, but Cedric's a blast. And to get to know other architects out there, I think that the classes of people over about the last 4 or 5 years to graduate from architecture school or design school, or those of you who are in the spaces that cross over, are really doing interesting work and interesting ways of thinking about it. If you want to look at something fun, look at my friend Fred Sharman's work. He's an architect. He's a professor at Morgan State, and he has a book coming out on space architecture, like space exploration, architectural histories next year. So fantastic stuff.
Throughout your talk, I think sometimes when you mention AI, like I would consider it as like more like human-computer interaction.
Mm-hmm.
The reason I'm saying that is because like I'm an engineer, so like when I get my PhD like more than 10 years ago, so like if you have a PhD in AI, it's not as easy to find a job as now.
Yep.
Right. So in my understanding, like we have a lot of breakthrough in AI, like core technology. I'm talking about like, for example, AlphaGo.
Yep.
Or like image recognition.
Totally.
Or if you look at like the IBM Watson, right? So when they won the Jeopardy show at that time.
Yep.
So we're talking about like there are different type of AI core technology advancement. And that's the reason it brings back the trend of AI. But this is quite different from what you're talking about, like the human-computer interaction. So, and I think IBM call it like cognitive computing. So, would you agree with me if like I try to understand when you say AI, it's more like human-computer interaction, which is not the core AI algorithm that we're talking about?
So, yes and no. Thank you for that. That's great. And to be clear, the focus of my research in this book is 1960, I mean, to some extent 1948, because I look at cybernetics a lot, but to really about 1977, 1980. The parts of the book that are focused on later material are not focused on questions of AI. And I agree with you that they are questions of human-computer interaction. But I would say that when Negroponte was writing this book, he was writing the book in 1970 and doing the work in 1970. He was developing interfaces with the AI lab, using their technologies in their environments and basically tinkering and working in that capacity. So yes, they are, it's input and output devices and all kinds of ways that the lab over that period of time played with that. It becomes human-computer interaction, but I don't think HCI as a field really kind of comes together in that term until the 1980s. I'd need to look at my notes to remember exactly when. I will say that I'm very curious about what happens in the HCI community around 1990, because there's some interesting crossovers that I think have things to do with HCI and interaction design in ways that are, in things that are really vital. And yeah, I would also agree with you that things are way more complex today, and I have skated by all of it. So my understanding of it is more nuanced, but again, I'm also I'm a historian of technology and architecture, and I'm not someone who got my PhD in AI. But yeah, when you start looking at it today and the implications and the different kind of terms that people are claiming, cognitive computing, deep learning, there's a whole different set of things to start looking at and studying their histories there going back to the 1980s and 1970s that I haven't yet gotten into. But it's, you're right, and yes, but no, but yes. Thank you for that.
Thank you so much, everyone, for coming out today. And thank you, Molly, for your presence here.
Thank you.